Hello, scholars. Welcome to day number 3 with our solar system book. As we get started today, let's talk about another element of nonfiction texts. After we warm up with a couple more glossary questions. So use the glossary to answer these 3 warm up questions. Number 1, what does diameter mean? Pause for a moment. Find that answer. Diameter is the length of a straight line through the center of an object. Right? So think of a pizza. If you were cutting from one side of the pizza to the other side of the pizza, right? Right through the middle, right? That's the diameter, right? The length of a straight line from one side, right, through the center of the object to the other side. The diameter. Question number 2. What do we call the path of an object revolving around another object? Pause. Find out which vocabulary word fits that definition. Did you say orbit? Good work. And question number 3. What is a meteor? Pause. Answer that question. A meteor is a meteoroid that enters Earth's atmosphere. Good work, scholars. So, the other element I wanted to talk to you about today is text features. Text features are another part of nonfiction texts. A text feature is an insert on a page of a nonfiction book that highlights important information. So, scholars, as we read pages 18 to 25 today, I'm going to point out text features along the way, right? Those inserts, those extra things that are added to the information. Now, remember, you can follow along with me while I read it aloud and point out those text features, or you can read it with someone in your family. But if you do that, make sure you're paying special note to those text features. All right, let's get started. Page 18. Right away, scholars, I see a text feature. This picture of Saturn with a caption that reads Saturn's spectacular rings are mostly made of water ice. Each ring averages about 30 feet in depth, but some bumps and points are more than 2 miles high. Right, so the thickness of most of those rings is about 30 feet, but there are spots, bumps, and points on it that are more than 2 miles high. Interesting. Let me read that information on page 18. Saturn. Saturn is the sixth planet of the solar system. It is easy to recognize because of its large, visible system of rings. The rings are made up of millions of pieces of ice and frozen gases. Saturn also has dozens of small moons that orbit it. Saturn is also unique for another reason. It weighs little compared to how large it is. Saturn would float if a swimming pool could be made big enough to hold it. Wow, that's an interesting fact, isn't it? So, if you made a swimming pool big enough for Saturn, it would float in that pool. It weighs so little. Interesting. Saturn spins very fast, making one day on Saturn 10 and 1/2 hours long. Then, scholars, we have another text feature, this illustration with a caption. 4 moons of Saturn pass in front of the planet. I'm not sure how to pronounce that. Enceladus, Enceladus, Enceladus. I'll have to check with Magistra Reynolds about that. Seems like it might have a Latin connection. And Dion, on the far left, casts shadows, while the larger Titan and the small Mimas at the far right do not. Hmm. So some moons cast a shadow, right? Based on where they are. Interesting. I'll have to look into those pronunciations. But that's a text feature, right? Giving us that insert of extra information. Before I read about Uranus, another text feature with a caption. Some of Uranus's moons and rings can be seen very clearly in this Hubble telescope image. The bright spots on the far right of the planet are high clouds. So you see those bright spots, everyone? High clouds. Isn't it good there's a caption there telling us what that is? Uranus. Uranus is the 7th planet of the solar system and the 3rd largest. It looks blue green in color because of methane gas in its atmosphere. Uranus seems to roll around the sun because it is very tilted. Scientists think this might be because it bumped into another planet sized object long ago. Uranus has at least 27 moons, 5 of which are large. Scientists have also counted at least 13 rings. It takes Uranus 81 Earth years to go around the sun. Wow. So, in the time, so 87 years go by on Earth in one rotation of Uranus around the sun. So, in one trip around the sun for Uranus, Earth has gone around it 81 times. Oh my goodness. Wow. Neptune. Did you see the text feature? So we have another illustration or photo and a caption describing what we're looking at. I'm going to read that caption first. Toward the top is the backward storm that scientists have named Dark Spot 1, and lower is Dark Spot 2. Can you see both of those, scholars? Their cyclone like winds spin counter to the direction of Neptune's orbit. So Neptune is spinning one way, and those two storms are spinning the opposite way. Neptune. Neptune is the 8th planet from the sun. Neptune and Uranus are sometimes called the twin giants because they are so much alike. They are about the same size and color, and both are covered with thick clouds. But Neptune's winds are the fastest in the solar system, reaching 2,000 kilometers per hour. That's over 1,242 miles per hour. Neptune has one large moon and many smaller moons, plus several visible dust rings. It takes Neptune about 165 Earth years to go around the sun. So, again, scholars, in 165 years on Earth, so Earth has gone around the sun 165 times to Neptune going around it once. Wow. So here, scholars, on page 22, we have a chart of information as our text feature, right? So what would you weigh? So it's a chart. If you weighed 70 pounds on Earth, your body would still look just like it is, but that's what your weight would be on different planets and on our moon, just because of the gravitational pull. Pluto and other dwarf planets. Before 2006, the space object called Pluto was the ninth planet of our solar system. But scientists debated and voted to create a new category called dwarf planets for space objects like Pluto. Dwarf planets orbit the sun, have nearly round shapes, produce a minimum level of brightness, and are not moons. They also do not have enough gravitational pull to sweep other space objects from their orbit. Scientists began by identifying 6 official dwarf planets, but some scientists wanted to classify dozens of similar space objects as dwarf planets. Many more space objects could be counted among the dwarf planets as technology makes it easier to identify them. So we have a photo with a caption on it as a text feature on page 23. Satellites monitor impact tests during research into ways to prevent asteroids from colliding with Earth. Hmm. Asteroids. Asteroids are rocky metallic objects orbiting the sun. They range in size from a few feet in diameter. Remember, a diameter, this a straight line through the center of it from one side to the other. So some of them are just a few feet thick, to hundreds of miles in diameter. Most asteroids are found between Mars and Jupiter. Some have orbits that cross the Earth's path, and in the past, some have even crashed into Earth. Asteroids and other smaller objects that enter Earth's atmosphere are called meteoroids. If they survive the trip and land on the ground, they are called meteorites. If they burn up before landing, they are called meteors. So if you've heard of a meteor shower, right? Those are then burning up and don't hit the ground or land on the ground. Among the best evidence of an asteroid hitting Earth is the Barringer crater near Winslow, Arizona. You've probably seen photos of that before. That very large, circular, like divot, right? Huge. Page 24, comets. The comet NEAT, photographed by the WIN telescope at Kitt Peak National Observatory in Arizona, was discovered in 2001 by the Near Earth Asteroid Tracking System, right? NEAT. Comets. Comets are composed of ice and dust and are like large, dirty snowballs in space. They have very oval shaped orbits. For part of that orbit, they come close to the sun and then they swing far out into space. Some comets orbit the sun in less than 200 years. The most famous of these is Halley's Comet. It returns every 76 years. Other comets take thousands of years to complete an orbit. Comet Hyakutake, which passed close to the Earth in 1996, will return in about 9,000 years. Conclusion. Humans have always wondered what's happening out there in space. For centuries, we could only guess. New rockets, space probes, satellites, and telescopes show us what's happening in our solar system every day. These tools have helped scientists to discover new planets, recount moons, and see stars being born and being swallowed. So, scholars, that idea of recounting moons, right? In our story about Wendy and Sydney, right, we've learned how many moons there are for Jupiter and Saturn. But since the writing of that book, scientists have been able to do more recounting, and those numbers have changed. They have also given us the first full sky survey map of our universe and a direct view at the sun. What will they show us next about our solar system and beyond? That brings us to today's assignment, Solar System Sheet 3. Remember, it is in your packet. Today, like our work previously, I'd like you to choose two important facts for Saturn, Uranus, and Neptune. Remember, they could be things that seem important, things you found interesting, right? Unique. You can decide what those facts are, but make sure you're listing two for each of those three planets. And then, question number two, do you think Earth is the only planet that can support life? Why? Use evidence from the book. So, what did you read that makes you think Earth is or is not the only planet that could support life? Remember, submit a photo of your sheet to your teacher so we can read through your important facts and thoughts on that question. Thanks for joining me. Tomorrow, scholars, we will wrap up our work with the solar system booklet. Thanks for joining me.